Hello, people. Today we'll be taking a look at recurrence relations. We'll be applying the tree method to solve for the time complexities. So I've laid out some steps that you will need to apply. You want to know the height of the tree. You want to know the series of the total work done at each of the level. Because tree is going to start from the root node, then you start going from the root node up to the leaf node. For instance, you have like this. This one will be another branch. Like this will be another branch. So this is the roots, right? So it goes to the leaf. So you want to know the height, okay? And also you want to know the total work done, okay? Then you want to calculate the work done at the base, because what we want to do is that we want to add the work done at the base plus work done before the base to determine the time complexity. All right, so those are the two things we want to add together. So if the work done at each of the level is uniform, what you just need to do is just to take one of them, multiply by the height of the tree. For instance, if at each of the level I'm having the same value, let's say I have n here, this level I have n, at this level the total work done is also n. So what I just need to do, just to say the n times the height of the tree, and that will give me my t of n. See that? That's what number 7 is talking about. So now let's go back to number 1. Number 1 says determine the tree height by the input reduction pattern. What do I mean? If t of n is 2t n over 2 plus 1, you see the reduction from n to n over 2. The next input is going to be n over 2, right? I've reduced it from n to n over 2. It's going to be 2t n over 4 plus 1. The next input is going to be n over 4. And this will give me 2t n over 8 plus 1. So let's see the pattern of the input reduction. So it starts from n, goes to n over 2. This one goes to n over 4. This one goes to n over 8. So take this as the series of the level of the tree. So the tree starts from 0, 1, 2, 3, and so on and so forth until you get to the base case, right? So you represent these indices by I. That means from this series, if I want to get a pattern in terms of I can say n divided by 2 to the power of I will give me any of the input at any time, right? So if I place 0 in place of I will get this. If I place 1 in place of I will get this. See that? Okay, good. Now, at the base case, I will equate this to 1 because the input is going to be 1, right? So then I will be log n. Okay? So how did I get this? I take, just multiply, cross multiply. So n goes to 2 to the power of I. Take the log of both sides to base 2. And that's why I have I equals to log n. All right? Take log of both sides to base 2. Okay, so with that, I've gotten the height of the tree. That's what the step number 1 is really talking about. All right, so what we're going to do now is to look at a particular example that would throw more light on what we are talking about. So the first example is Tn is equals to 3Tn over 4 plus Cn squared. See that? So firstly, let's look at the input reduction pattern. That means T of n over 4, which is the next input, is going to be 3Tn over 16 plus Cn over 16, then square the n, because it's n over 4 all square, so n square over 16. Then when the input is n over 16, what I have is 16. I have 30n over 64 plus Cn square over 16 square. See that? So now I want to see the input reduction pattern, which is n, comma, n over 4, comma, n over 16, comma, n over 64. This will continue until you get to the base case. All right. So based on this, I can say that the pattern is n divided by 4 to the power of I is equals to 1, which is at the base case. Okay. Then I can say I equals to a log n base 4. See that? Log n base 4. With this, I know the height of the tree. All right. So now I want to know the pattern of the work done at each of the level. So based on these equations, I can see what the pattern will look like. You see this? See this? What I just need to do is to start multiplying each of these by 3 and by 9 from the second level. So now the first work done is Cn squared. Okay. The second work done is giving me Cn squared divided by 16 for each n by 4. Each n by 4 produce Cn squared over 16. So if I have 3 Tn by 4, what I will get is 3 times Cn squared over 16. So that's going to be the next work done. So it's going to be 3 Cn squared over 16, right? Then the next work done is going to be this. So remember that this Cn squared divided by 4 is produced by 1, right? So now at this level, when I have n divided by 16, you see what this guy produced. This guy produced Cn squared divided by 16 squared. See that? So you want to count, the total number of times that will be produced, right? So we'll get there. And that will give me 9, right? 9Cn squared over 16 squared. So why did I say 9? Because each of these, look at this, each of these, Cn squared over 16 was produced by a singular Tn over 4. That means n over 16 produce Cn squared over 16, right? 3 times. You see that? Because this guy is for 1. That's the same thing you see going on here. So that's why I have Cn squared over 16 squared. So based on this now, I can tell what the pattern will be. The pattern is going to be Cn squared times 3 over 16 all to the power of I. See that? All to the power of I. And that will give me any of the work done at any of the level. Okay? So, good. Take note of this one. This is one of the pieces we need also to get the final solution. Now, we want to look at the total solved problem at each of the level. So, we have T of n producing 3 solved problem. That means this 3 solved problem will produce another 3 solved problem, right? So this is going to be 1, 3. This one will produce another 3, which is 9. This one will produce another 3, which is 27, and so on and so forth. So these are the total solved problem. If you go back to this tree, just look at this tree. You see this tree? See this tree? Count them. This one is producing 9. So what you have now is like 1, 3, 9, and so on and so forth. The next one is going to be 27. So that's the series I'm referring to. That's like, the total number of solved problems you're going to keep getting. And the pattern for this now, is going to be 3 to the power of I. Because if this is 0, 1, 2, 3, until you get to your base case, and this indexes is like I, then I can say 3 to the power of I will give me the total number of the total or solved problem at any of the level, right? So long I know what I is. And now I is the height of the tree. 3, right? So now I can say that the total subproblem is going to be 3 to the power of log n base 4. And this is the same thing as n log 3 base 4. So with this, I already know what the base will be, right? So the base case, the total number of subproblem you're going to get is still going to be 3 to the power of I, right? So I'm going to say, so work done at the base case, at the base, is going to be n to the power of log 3 base 4 times 1, because it's always a constant time to get the base case to be done. So this is n to the power of log 3 base 4. Now I've gotten this ingredient. So with this, I've gotten all I needed. All right. So these are the things I'm going to use. One, this is at the base case. I'm going to use this. Then I'm going to use this. Then I'm going to remember the height of the tree, which is this guy. So those are the 3 things I needed. So I just come here, I just say T of n is equals to the sigma of I equals to 0 up to log, which is the height, log n base 4 minus 1. I'll tell you the reason why I'm subtracting 1, because I'm going to add the base, n to the power of log 3 base 4. Because I'm adding the base, that means the base is not inclusive in this sigma operation, so I'll subtract 1 from the upper bound of the sigma. So this guy now will now be Cn squared 3 over 16 I. So with that, I want us to solve this part, this first part first, then we'll add it to this guy and just tell what the time complexity will be. So that means what I have for the first part is Cn squared sigma of log n base 4 minus 1, then 3 divided by 16 all I, then I equals to 0. So with this now, I already see what the pattern will be. It's going to be from 1 to 3 over 16 to 3 over 16 all square to 3 over 16 cube, and so on and so forth. Because the I will be increasing. So based on this now, I know that this is a geometric series. And I tell the common ratio is 3 over 16. And this common ratio arrow is less than 1. And when it is less than 1, based on your formula, you can apply 1 minus arrow, right? A divided by 1 minus arrow. And A is 1, which is this first term. Then we know what arrow is, right? So we have 1 minus 3 divided by 16. And what would this guy give you? It's going to be 16 divided by 13. See that? So that's what this guy will give to you. With that said, I can now tell that Tn is going to be Cn squared times 16 over 6. 16 over 13 plus n to the power of log 3 base 4. So when you have something like this, you go with where you have the highest growing term, right? So T of n will now give me big O of n squared.